My dear students, in today's class, I am going to discuss refractive index of a liquid. Before going to discuss refractive index, you must know the phenomena of light, that is refraction. Refraction means when a light radiation is traveling from one medium to another medium, it changes the direction at the point of incident. So this phenomena is called as refraction. So we know that the light usually travels through straight line, but when it is traveling between from one medium to another medium, it changes the direction at the point of incident. For example, you observe here, so this is a air medium and this is a water medium. When light is traveling from ear to ear, it changes the direction here. Instead of going straight, it changes the direction. So this phenomenon is called as refraction. Along with that, when the speed of light is different for different medium. The speed of light in a vacuum is, we know that is a 3.3 into 10 to the power of 8 meter per second. This is the speed of light. But the velocity of light is different for different medium. Why? Because in a vacuum it doesn't have any atoms and particles. But if you pass the light to the medium which is having atoms and particle, at that moment these atoms either they are going to absorb that radiation or they are going to re-emit that radiation. So this absorption and re-emission phenomena affect to the velocity of light radiation. So because of that, the different medium so possess the different velocity, and this velocity is also depends on density of the medium. So the refractive index, it deals with the velocity of light between two medium. That is, when you pass the light from one medium to another medium, refraction takes place. So as a result, the velocity of light is different in two different medium. So the refractive index is nothing but it's the ratio of the speed of light in a medium relative to speed of light in a vacuum. So this can be mathematically indicated as n is equal to c divided by v, where c is the velocity of light in vacuum, this c is the velocity of light in vacuum, and v is the velocity of light in a substance or in a liquid, air, whatever, that is in a substance or in any medium. So this is the mathematical expression, n is equal to c divided by. And if you observe here, this refractive index, it is inversely proportional to velocity of light in a medium. That is, if the velocity in the medium is more, refractive index is less. And this velocity depends on the density of a medium. If the density of the medium is high, the rays are slowly moving. As a result, the refractive index is increases. If it is less denser, at that moment the velocity is more and refractive index is less. That is, the refractive index, it is inversely proportional to the velocity of light. Now let us understand the factor which are affect on refractive index. The first factor is temperature. The temperature which is inversely proportional to refractive index. So this is because, so at high temperature, you know the property of substance at high temperature. At high temperature, so the force of attraction between the interparticle is very less. So if the force of attraction is less, so the density decreases. If the density decreases, the viscosity of the medium liquid also decreases. If the viscosity is high, the light travel faster in that medium. And so if the v, if you look at this mathematical expression, if v is more, at the moment the value of n is decreases. But at low temperature, so the viscosity is increases. You know the relationship between the variation of temperature and viscosity. At low temperature, the viscosity of the medium is high. As a result, the velocity of light is decreases. If the value of v is decreases, so the refractive index is increases. That is, the refractive index, it is inversely proportional to the temperature. Second important factor is wavelength. That is, the refractive index varies linearly with the wavelength of light, that is, it is directly proportional to the wavelength of light. And during refractive index studies, we are going to use a monochromatic light to prevent dispersion and other phenomena. Why? Because if you use visible radiation, it has 7 different colors. All the 7 different color possess 7 different wavelength. So obviously we are going to get 7 different refractive angle or angle of refraction. So at that moment it is very difficult to identify the refractive index of a liquid. That's why we prefer a monochromatic light. That is, the monochromatic light is one, so in which it has single wavelength. So this usually we are going to prepare sodium D line of wavelength 598 nanometer in refractive index studies. That is, to measure the refractive index of a liquid, we are going to use sodium vapor lamps of wavelength 598 nanometer. So here, if you look at this graph, it shows that so the red color radiations, it has high wavelength, so its angle of refraction is more. And the last one, so violent, so it is less wavelength. As a result, the angle of refraction is less. That is, the wavelength of radiation, it is proportional to the refractive index, because more wavelength, it travels more, and its velocity is less. That's why the refractive index is more. And measurement of refractive index. The refractive index of a given liquid can be measured with the help of an instrument. This is called as Abbes Refractometer. So this is Abbes Refractometer. So before going to understand the measurement of refractive index by using Abbes Refractometer, you must know Abbes Refractometer. You must know the so in the Abbes Refractometer, it is looking like a microscope, and it contains more than 5 important parts. The first one is it contains one small telescope, and it has eyepiece, so through which we can observe the angle of refraction which is coming out from the prism. And here, so more important here is prism box. So what we are going to do is, so in order to measure the refractive index, you have to pass the light between two medium. Here we choose, so the prism is a one medium, and liquid, the unknown liquid or the sample liquid, is a another medium. But so here we are going to use two prism. Between two prism we are going to place the sample. So this is a prism box, this is a light source, and this is a prism box. This is how we can open the prism box, and we can insert minimum 0.5 ml of sample. So between the two prism box, then we are going to close it. So here, see this chamber in which we are going to introduce the sample, and this chamber contain two prism. So which two prism, so in between these two prism we are going to introduce a sample, and it contain one mirror. This mirror is going to reflect the light to the prism, and it containing one scale. This scale directly gives the refractive index of the liquid, which is based on the angle of refraction. And this is the knob. It contains two knobs. One is on the right side and another one is on the left side, in order to measure and in order to magnify the rays which is coming from the prism box. So this is about Abbes Refractometer. Now let us understand the principle of this Abbes Refractometer. You look at this diagram. So this is a telescope through which we can observe the refracted radiation which is coming from the prism box. Here, so this is one prism, this is another prism, and in between here we are going to keep the sample. This is a sample area. This is where we are going to keep the sample. So when light is incident on this prism, and it passes, and here it change the direction, and again it change the direction, and directly it projected towards telescope. Here different liquid so refract in a different angle of refraction. So if you know the angle of refraction, you can easily calculate the refractive index. The refractive index of unknown sample can be calculated by using a refractive index of known sample. That means here we are going to use a prism. We know the refractive index of a prism. So by using the refractive index of a prism, so one known substance, the refractive index of an unknown solution can be calculated with the help of Snell's law. Let us look at the detailed working of this Abbes refractometer. So when light is incident on this prism, so we know that, so we have a mirror. So when light is incident on the mirror reflect the light and which is incident on this prism, and this incident and it refract and it is projected, it is directed to telescope, and the light rays entering the sample moving in the different directions. That is, if different sample, so obviously moving in a different direction due to different angle of refraction, and these refracting prism produces light and dark region like this. If you observe through telescope, we can found that the prism produces light and dark region. You look at this figure. In the figure, so there is a cross wire, and so half circle is white color, another half circle is dark. So this kind of image can be seen if you see through the telescope, and the sample with different refractive index produce different angle of refraction, and which causes the shifting of this borderline between dark and light region. This shifting of borderline or the borderline position which is produced from the prism, so it is a key, or it is used to establish refractive index of a different liquids. Now let us see the working procedure of this Abbes refractometer. So in this Abbes refractometer, first we are going to clean the prism by using ether. Then we are going to blow the air and we are going to dry the prism. And to this we are going to add 0.5 cc of liquids between the two prism. Then we are going to focus the mirror. We are going to focus the light. We are going to focus in order to get the reflect light which is coming out from the prism box, and we are going to turn the light, and we are going to by using a right hand knob we are going to adjust the color fringes, and then we are going to make it sharp by rotating right hand fringes, and with the help of left hand knob we are going to adjust, we are going to magnifying that, then the line of demarcation. So here you just look at it. Sometimes this is important. As I told, suppose if the refractive angle is more, at that moment the line of demarcation comes here. If it is less, the line of demarcation comes here. As I told, the position of this line of demarcation, that is the prism which is going to produce light and dark region. So the dark region comes up to here. In case of refractive angle is more, it comes up to here. If refractive index is some more, it comes up to here. So then we are going to adjust this demarcation so to the center point of this cross line. So if you adjust this adjustment is depends on the refractive index of a given liquid. So if you adjust, then by using the scale exactly we can measure the refractive index up to 4th decimal. So this is how we can calculate the refractive index of a liquid. Dear student, the refractive index is very simple, so that we can calculate with the help of Abbes refractometer.